Hello, hello. Wait. I'm waiting. Big early. What are we waiting for? We're good, continue. Is it the first time Pigorli claimed first? Alright. We're going to work on cast today, and also I don't know if you can see the screen here. I'm setting up Windows on my laptop because you know. I'm going to work on continuations. I'm just going to finish what I was doing. Please continue. Okay. All right, so we're working on this example in minicast here. We have a delimited continuation, which is transpiled to C already, I think. The only thing that's missing is doing the capture continuation stuff. And we need to transpile that to C, so backend C lib. There we go. Over here somewhere we have capture continuation, and this is a to-do. So let's do something that's not a to-do here. The delimited continuation creating that actually is already almost 200 lines. I think this one is going to be actually short, and then we can play around with this thing. So we have capture continuation, we have the delimiter. And then the identifier for the continuation. And the expression that we need to evaluate as a substitution for the value that we are that we are getting here. Temp streamers you follow are live right now. Nice. You can open up 10 streams at the same time. If you have like 2 monitors, that would be like 5 streamers on every monitor. And if you are like Pigorli and you have like 5 monitors, you can just open 2 streamers on every one. Right, Pigorli? Right. Token is here. Capture continuation. Okay, we have the token. So token is the expression. The first thing that we need to do is we need to calculate the token. So say calculate token. right? And that is the expression that evaluates to the delimited continuation token, right? Yep. Then so the delimited continuation token is a thing which we specify over here. It contains the coroutine inside, right? Just mcol coro is there. Yeah. And what we need to do is just we just need to let's just say coroutine. This is the let's say that this is an expression. It's going to be a field of object which is object is token. The field is the quorum, right? And that is my coroutine. Okay. Where's my example? Test C, this one, right? So what we need to do, we are doing what am I doing? Capturing continuation, right? I need to specify what is the continuation, so the K, right? K is the context, which is the coroutine, and the function is when we resume the coroutine, yeah. And this is a function returning an int. Hello, I'm soft. What am I compiling into right now? Yeah, we have this. We have resume delimited continuation int function, right? That takes the delimited continuation token. Resume delimited continuation function. Yeah. I kind of forgot. All right, it is going to be slow, but we'll get there. I'm sure. This is when we specify this in minicast. Like, in my test here, this function, yeah, because this over here is the type of a function returning an int, right? Which is like a closure, right? So we have a function which takes the context, which is the captured environment, basically, right? And all of the extra arguments, which in this case are none. And by the way, we should not have the extra argument, which is the like this context is different. This is the captured context. But there is also the implicit context argument always, which is different from this thing. It's a little confusing that it also is called context. But if so, like this means that this is a closure in the C-colon convention, because we don't have the implicit context as the argument here, which is what we usually have for our functions. But anyway, so like we need to create this continuation, right? And assign this to the k variable. And then after that, we need to yield the coroutine. And before yielding, we also need to send the data. And the data is the result of us evaluating this expression over here, the 456. And in order to evaluate this expression, I already need to have the continuation, by the way, which, I mean, yeah, it, I guess it does make sense. All right, so we have the coroutine. Let's start by the pausing, the yielding of the coroutine, right? So I'm just going to insert mco statement, which is applying the function, which is mco yield. The args is we just need a single element list, which is the coroutine itself. Yeah. And before that, we need to push there. Yeah, we do mco push. Before yielding, I need to push, and I need to push the result. Let's call this result var. Let's say result var is new identifier result, because this result is a result of me evaluating the body, right? So we need to calculate the body. I also only need to push if it is not a unit, right? Yeah. Yeah. So we say that if body type is unit, then we do one thing, but if it's not unit, yeah, so if it's unit, we just say I still need to calculate the body, right? I just don't care about it. Or I guess, yeah, we just calculate the body, but we don't do anything with the result of it. And in this case, the calculated body, we need to assign this to a variable, which is the result variable. We let var the type of the variable is body type a result var, and it should be calculate body. It should be pure. Calculate body. And now we can push it here. Okay, I mean, is that all I need actually? Potentially. It's compiled. Just see this. Okay, so the only thing is that the K is undeclared, right? Because that's my coroutine. Co is undeclared too, though. That's a different issue. Right? Yeah, there we go. We say resume is K. But we need to specify what K is. The result is 456. And then we push into coroutine the result, right? Yeah, I see. It's because the co... yeah, it's not the co here. It's not the identifier co. It is the literally just the core here. So the only error that we should get is that the K is not specified. Oh wait, it also says that A is undeclared. Yeah, and the reason A is undeclared is because we are inside of the delimited body. Oh wait, we are inside of a delimited body, so we actually have the access to the coroutine. We have the captured context actually here too. I'm not necessarily here though, right? Because this can happen, capturing the continuation can happen from the inner call, from a nested call. But what we have... No, but what we have is the A, right? And A is the name of the continuation of the delimited block, right? We are just not having it there. We do have the delimited captures, right? And delimited captures contains the A. There we go. This is here, which is not mm-hmm. Let me see. How am I getting the other captured variables? Am I accessing them by the... So, like, we have the captured variable, basically, in scope, right? Yeah, in this scope, we have the captured variable. And inside of the captured variable, we have the A, right? It's supposed to be a captured one. In case we're capturing other variables from the outside scope, that should also be the case. Let me see what's happening if I have over here, you know, for 456 FFs, and it's 456, and then we say over here that we return FFs, right? Because that's going to also be captured here. Yeah, over here, you see, we say FFs is actually the captured one. So we, yeah, captured FFs. Right. And we need to do the same for the A. And how am I doing that? How am I doing that? It is when we have the place expression. When we calculate the place, right? If we have the identifier, we say find identifier. And the find identifier, it says that if the current function context contains the name, then we need to get it from the captured thing, right? So I just need to insert it there. Yeah, I just need to insert it there. And with a function context, so these are the captures that we have. This is the captures that I have here. Add function impl. So the captures that we have calculated for the delimited continuation is the captures excluding the token. But what we can do really easily is, since we have the token name here, I can just assign it over here. We can say let var. Let's do insert state. Let var the token name. I'm just going to get it from the captured, I guess, right? Yeah. Yeah, sure. That's okay to do that. It's going to be a field where object is deref. Yeah, it's similar to the context, which I'm already doing, right? Because I'm also capturing the context. So I have the captured thing, and the field is going to be the token name. Same as context var. But the type of this is what? It's what's the type of token? It's just token type representation, token type wrapper. We already have it here. This might be it. I mean, almost. That says it for that error, which is error A is undeclared, right? So now we have only one error left, which is K is not declared. Because now A, the delimited continuation token, we get it over here. Delimited continuation token is the one in the captured. Okay, sure. Why not? All right, so what is the continuation? This needs to be of type function type 22. So this is a function type. Because this is like a closure, right? The raw function is the one that is not closure, so it has the void star, which is the captured, and this is the context, right? But wait a second. Yes, and I did not want to have the context there. Yeah, what should be the type of the continuation? We also could have the continuation to be its own type, but then I would need to wrap it in another closure, I suppose. Right? I mean, technically, having a dedicated type for continuations is probably makes sense, right? I'm not sure about a lot of other languages, but OCaml continuations definitely have a dedicated type for them, right? Boom, 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 boom. OCaml effects. Let's see. So this K is having the continuation, delimited continuation K, suspend computation between the point of perform and this handler. Right, so this is the type. We have the continuation type in OCaml, which has a int and a status. So it has two type arguments. The type int a status continuation says that the suspended delimited continuation expects an int value to resume and returns a value of type a status when resumed. Oh yeah, I get it. Yeah, okay, got it. Yeah. Right now we are starting with the continuations, just having no arguments, but yeah, that makes sense. That does make sense. So I think we might want to have a dedicated type for it. So how about this? Why do I have resumed continuation? I don't know. Continuation token. What we want is to have the continuation. Right? Continuation. You know, and you know what I just realized? I cannot even have, like, I cannot have a template which would expand into multiple arguments, right? Right, like if I want to have a function with a number of arguments depending on the template, in C++ you would do like what, t dot 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 or something maybe? That is not supported in minicast right now. We can have the return type. But yeah, I mean, maybe I don't know if I want to support that. So we can represent the continuation as just the function pointer, right? Which the function which returns r. So it's going to be r f with no arguments. Wait, what? That I'm not writing C, right? I need to write this. I would need to say f is a function, the C calling convention function. I also do not support the types for like raw functions right now. So this is already going to be a closure, which takes no argument and returns R. Right. I mean, technically this would be everything that's needed then. And then we could have a function, like we could change the representation here potentially. But then we say can resume continuation, right? Which is going to be our continuation is continuation R, and this should just return R, which is just me calling the continuation.f technically, right? And the reason why this is different, because this is now not a C calling convention, but a regular calling convention, right? They gave minicast calling convention. And the reason for that is, well, I mean, yeah, because over here I'm trying to store the resume as this function. It doesn't have to be low. Yeah, we can also say that resume. I don't know. It's okay. We can say over here that this is a closure that is doing resume continuation and k, right? Like that. Because k is the continuation here. And this is a closure which needs to own the continuation, so it must be a move closure here.
Hello.
Hello. Oh. Welcome. How are you doing? Mini coroutines. Yeah, we're working with mini core library here in C, and technically I'm trying to implement delimited continuations still, right? But I mean, the difference between the delimited continuations and coroutines is like, I'm not sure if like it's just a little technical distinction, I guess. And we're adding the support for that to minicast. And the only thing that is left for me is actually like constructing the continuation object here, supposedly. when I'm capturing the continuation. Yeah. So this continuation name is the identifier. Continuation name is identifier. And this identifier needs to be created here before we even calculate the body, right? So around over here, and to say let var, I need to say let var I need the continuation type. Type. It's a little bit weird here. Maybe I will fix it eventually, but I'm storing the type of things sometimes because I need to instantiate the generic before going to the C backend. Yes. So we have continuation type wrapper. Continuation type representation. So that we need to create the variable which is named continuation name. The type of this variable is continuation type wrapper, and the value of this is the this is what we need to figure out, right? The value of this well, this is the C backend specifically, so we know what the representation is. It is this as C calling function. So I'm going to say it's a compound literal of type being the convert type continuation type wrapper. Like we are constructing this thing with only a single field, which is having name f, right? So we initialize this field, and this is going to be the closure. This type right now is already a closure, which has the captured make sure all types are defined in the continuation type wrapper, maybe also. Not sure if that's needed. So the value would be another compound literal, right? With the type being convert type continuation. You know what? Let's. So like I think yeah. Let's do it later. A little bit differently. What we want here is literally a raw C function, right? I cannot like have a type like that though. Can I? Let's say continuation function. Continuation function, right, is a type of so we are going to create a type alias here. Wait, I cannot create the type alias because C is weird. um. Because the type is like both before and after the identifier, especially when you define the function pointers, right? Like what I want, maybe I can just do this. What should be the syntax for defining the raw? So like we have the arrow type, which is the type of a closure, I think, by default. I think that's okay. Because most of the things are going to be closures. I think that's fine. But if I want to have a raw function, I could say function. We can have a function keyword. I think that's fine. Right? It's a function with C-calling convention from nothing into R. And what it does is that it is literally just a function pointer. Then. Yeah, I think that's fine. And it would still be possible to call it? Yeah, I think so. Let's have the syntax for it. So function type and function. I think both of those. Let's have it for the function type for now only. Let's say raw function is an optional group with the function keyword like that. There we go. That's all that I need to do. Right, and this should pick up this new syntax. There we go. So since f is the raw function, the function that I want here is what? No, but this raw function is going to have the Coro as the argument. Right, plus we have the Coro here. So we like do a custom closure. Right. And the only difference between the regular closure has the void star, and this is the mcora star. Right, so I need to yeah, it's not a single element list. Let's say there's latmut fields push back Coro field and the f field. This is f field, which is just a function. It is not going to be a compound literal. And Coro field is name is Coro, value is the Coro. We have that here. F. So the only thing that is left is having the function which can perform the continuation. It is this one, right? We have resumed delimited continuation. It has the coro inside of a token. It also actually, you know what? This can have the token instead. Yeah, maybe I just have the token, which is the delimited continuation token R, and this takes the delimited continuation token R. Like, and this is literally the function that I need, right? Resume delimited continuation. And I do the manual mangling and stuff here. It's a little bit weird, like to name that function there. Resume continuation token. Let's do that. Oh, we have resume function. It is a part of the delimited continuation, right? Yeah. I guess I need to have the same, but for the thing, right? We have this resume function. Yeah. And the same is going to happen for the captured continuation resume function. Right, resume function. This is it. So f is just identifier. Resume function underscore fn is okay. Yeah. So what I added, we have the capture continuation. This needs, similar to this, have the resume function as a string. That's like the identifier of it instantiated. We also need the continuation type representation, which is a type, right? So when I parse expression, the resume function, when I capture continuation, the resume function can be instantiated delimited resume delimited continuation token is what I renamed it to, right? So we instantiate this with a single element list being the result type. Sure. And we need to have the continuation type wrapper, which also is going to be instantiate type. We're going to instantiate the continuation with the single element list being the result type. Right? There we go. This may be everything. But probably not. I probably forgot something. It compiles, but does it work? Expected 1 arguments, got 0. Continuation f. Oh, yeah. So like now this is a function, right, which just takes the continuation token. So, and token is literally just stored inside of the continuation, like this, right? So this is like it's like a manual closure here. That's okay. All right, over here, k. Expected type continuation int, but got unit into int. Okay. I think yeah, that makes sense. I think that's the type checking of capturing continuation. Right? When I capture the continuation, I know that the continuation has the continuation type, which is a function type, but it should not be continuation type. Actually, this is the continuation type, literally. Right? Continuation type is this. We should say instantiate the continuation like that. Expect type unit got int because resume continuation. Right, because I don't actually infer the types for the closure. I need to specify that this returns int. Right now. Okay, now it is compiled, but it is not compiled into C because we don't have the coro. Right, because we are, because it's not the coroutine actually that I need the token itself there, right, as a field. We have the token instead of the coroutine, so it is token field, and token field is the token, literally. That's all? Do I even need the coro then? I mean, yeah, it's used for pushing the data and yielding. Imagine if it works first try here. We have segmentation fault, but I was capturing continuation and I'm printing 456 here, right? I think it's because I don't have the move closures implemented properly, probably. Right? Where's my code? Can I go to here? So this is the delimited continuation, the delimited body here, right? We are getting, so I'm printing the 456, by the way, right? I'm printing the 456 and I'm printing capturing continuation, right? So I've printed that. Then I have actually executed this code and returned the FFs from here. So I have printed as the result over here, the X becomes the FFs, which is 456, right? But then we are trying to call the resume function, and we are not allowed to do that because the continuation is from this thing, which is dead now. Yeah, this is why we do the segfault. It does the address of 00 though, which is like weird though. Can I say, am I calling this closure at least? How about that? Print string resuming continuation. Let's try that. Let's try to see if this is going to be printed. Yeah, it does print it, right? But then it doesn't actually resume anything. We can also try resume continuation. Runtime over here. I mean, resume continuation, this just calls this function. Right, but this, yeah, I think I want to see the implementation of this function in my compiled resuming continuation, right? So this is my closure, right? We have the captured void. Captured, right? So what are we capturing here? We're capturing the continuation k by value. Yes, actually, wait, did I implement the moving closures? I thought there was something wrong about them. Oh, wait. No, never mind. Never mind. Resuming continuation is here. If current, yeah, add that, whatever. Can I see the exact line where it happens? How do I do the concrete line? I need like to run this through Valgrind or something. I thought I was supposed to get right, this is the address sanitizer. Is there a line somewhere? Address sanitizer cannot provide additional info. We have register values. Address points to the 0 page. It definitely has something to do with closures, and I didn't finish something about my closures, right? Let's try Valgrind next. Why is my Valgrind is not even installed in this thing? I think it should be, right? Let's install Valgrind. It needs GDB. Valgrind. Target compiled. Is that not what I'm running? GCC output is target compiled, yes. We do ggdb. Target compiled. Yeah, this is the code. Well, grind. asn runtime does not come first in initial library list. You should either link runtime to your application or manually preload it with ld preload. It doesn't work with asn. Should I compile it without asn? Without sanitizers? Like if I get rid of this and I would do val grind here, right? Okay. Right, so it says, yeah, over here, it says resuming continuation. Warning, client switching stacks. I am switching stacks, that is true. Can I get rid of these warnings? Because I am switching stacks. Jump to the invalid address stated on the next line in main function. Compiled C. Oh my god, the fact that I can just not click on it is so annoying. Because it's in the target compiled C, not just in compiled C. Line 552. Yeah, this is me calling the resume. Right? When I'm resuming the continuation, yes. So we jump to the invalid address stated on the next line. Address 00 is not stacked, locked, or recently freed. Wait, does it mean that resume was never actually assigned? It's this field, right? This field is over here initialized. When I was capturing the continuation. Right? Closure 69 FN. It says jump to the invalid address. Like, what exactly is the... Like, on this line, we have three things. We have resume.f, resume.captured, and this thing. What is the jump? It's because I'm calling, right? So it's because of the f. So f is null, which is the raw function, which is the function pointer, right? That stuff is null, because that would mean that is the only thing that we would be jumping to the function call, right? I would assume that the error message is going to be different if I'm trying to dereference a null. This is a jump. So resume.f is equal to that. And resume is captured over here. And it is assigned to over here. And f, in this case, is this function. So I literally have not ran over this code, maybe. Right, we say resume is equal to that, right? Can I say over here print string resume assigned? Because this should have happened, right? Resume assigned, it was assigned indeed. How do you debug C? Is debugging C a thing that is possible? Debug. GDB launch. Program. Enter program name. Open launch JSON. LLDB. Please download and install the JDK. What? Debug. Create a launch JSON file. LLDB. C++. The button just doesn't work. Okay, VS Code is not working. That's fine. Alright, how do you use GDB? I never used it from command line. Hello, Elemental Magix. GDB program. Right, so do I just literally do GDB? And to install it too. Should I use LLDB though instead? Since I'm compiling... Am I compiling with Clang or with GCC actually? I'm not sure. With GCC, right? Yeah, sure. Let's install GDB. GDB on Linux, is it better? I know that with Rust I was using LLDB, I think. For whatever reason. Cancelled. What do you mean cancelled? I didn't cancel anything. GDB target compiled. Okay. So, and then we want to, like, what? Question mark, help, breakpoints, help breakpoints. B sets breakpoint at specified location. How do I specify the location? B. No default breakpoint address now. Help B. Set breakpoint at specified location. Location. Break probe modifier location. Location may be a line spec, address, or explicit location, as described below. The fact that it's not a pager, but like press enter for more is like what? I mean, sure. Is there like a more modern front end, which is still TUI? Because this is like, I'm surprised that this is an emoji actually. Here, then, if they do press red for more. Anyway. How do I specify the file, line, and column? We can also specify a function, it seems. Specify a function and basically run the functions in all scopes. Line specs are column-separated list of location parameters, such as source file name, function name, label name, and line number. So we can say factorial C fact. The top. What is the top? To specify the start of a label named the top. Oh, we have labels there too. Got it. Okay. Okay. So what we want is to set breakpoint. Resume dot f is being called over here, right? Actually, like, I just want to have this line 561. Can I just say line 56, like, can I just say break 561? Yeah. And then what we do, just run, right? And I am now on this breakpoint. So I have captured the continuation, resume has been assigned, I printed 456. And now I want to say what is f. And for step, yeah, I want to like I want to see what the variable is, right? Is it examining the stack, examining data? Dump binary, dump a memory. Can I like dump a value of an expression? To the raw binary file? I don't want the raw binary file. Explore a value or a type valid in the current context. Is that what I do? Explore. Do I just do explore resume? The value of resume is of type function type, which is a type def of type struct function type. Okay, sure. The value of resume is a struct class with the following fields: captured, enter 0 to explore this field of type void star. Okay, sure. And I want to enter 1. The value of resume.f is of type this. Resume.f is a pointer to a value. Continue exploring it as a pointer to a single value. Yes, what is the value of the pointer? Can I just see the value? The value of resume is a struct. What? No. Why do I not still see the value of the pointer? Display. Print value or expression each time the program stops. Display resume. There you go. Resume captured is this and f is that, right? I mean, wait, hold on. Does GTB also like does the check for seg faults or something, right? It says program received signals, segmentation fault, but where? This does not tell me where. I mean, in this specific line, I know that it happens here. But this is not null. And this is not null. And this is not null. So, like, none of the things here is null. Right? But the error that we say is that it is literally a 0 thing somewhere. So where is it? In question mark. Or is it like inside of this function call? I should like step into this call, right? That's probably it. Do I just run the program again? Start from the beginning? Yes. Over here we have a breakpoint. Can I step into the function? Is there any breakpoint in GDB? Show functions? What? There is no show functions. Undefined show command functions. Help show. Even show breakpoints. Info functions. All defined functions. Non-debugging symbols. Oh, we can continue without paging, like that. I don't know, is that helpful? You prefer GDB UI? I mean, I would prefer to use the... I don't know why it's not working here. Like, I can literally not... I mean, that's the UI, right? The VS Code. I should probably also learn how to use it in the Neo Vim with the dep, because I will want to have the debugger for cast 2 at some point. But I cannot even initialize this thing. It says activating extensions, and then it doesn't activate. It's just broken. You say is there like a thing which is called GDB UI? GDB UI? Is that what you use? Or you say GDB UI? No, UI, no such file or directory. What is the UI that you use? GDB UI. GDB UI? Browser-based front-end? Browser-based? GDB UI. It's not in Linux packages? There's no way. There's GDB GUI for some reason. It's called GUI. GDB GUI. Address is already in use. What address? Address 5000? Oh, it is. It actually is already in use. Can I change the port? P1234. Opening this over here. All right, let's go. Is that what you use? Welcome to GDB GUI. This guide can be shown. Dismiss. And we can say GDB here. Can I set the program? Show file system. Hide file system. Load binary. Oh yeah, over here, right? We say the binary is going to be target compiled. Okay, there we go. There we go, and we are here. Is it already running, by the way? Continue until breakpoint. Program is not being run. Wait, what? Continue until breakpoint. Start inferior. Like, why is this text under my mouse cursor and I cannot read it? If I move my mouse, then I don't see it. Okay, there we go. We just wait for the mouse to disappear, I guess. This is so... like, why is everything so annoying? Start inferior program from the beginning keyboard. Shortcut R. What is inferior program? We want to start superior program. We now have breakpoint at line 652. Okay, continue. And then we have the segmentation fault. Okay. Question mark is 0, right? So, what do you mean question mark? Yes, I think it's because it's in the inner call, right? Minicast main. Can I go to the... main FN over here? If I go this place, we can start the program. I am here now. Okay. Can I hover? Yes, I can hover. Nice. Can I zoom in? So we have resume. Yeah, there we go. Captured F is something, right? So can I step into the next function? There we go. So this is my function that I'm calling. Right? The captured is that. Context is something. Step over the next function call. Print string, this is a resuming continuation, is going to be printed properly, and then we are not unwinding after that. And we say resume continuation int f captured. There you go. This captured is 0. Right? That's the... Wait, what? Oh, I think if I'm hovering on the captured here, it thinks that I'm hovering on the local variable named captured instead of hovering on the field. Okay. Because it just figures out the word, which is under the cursor, which is why this is a little bit confusing UI here, right? But the resume continuation int is a function where captured is 0. No, that is fine. That's because this is a function which is like a global function. I'm still like converting every function to a closure, which is just not capturing anything, so it doesn't matter. Captured K. And we have the token with the coroutine, okay. Resume continuation. Okay, I mean, sure, let's try to step in. Resume continuation in fn, let's step in. So we have continuation f dot f. Oh, there we go. Continuation f is 0. Continuation int. And f... Yeah, I have specified the captured, but f is 0. Why is this 0? And if I do step in, then, yeah, cannot address 0, and we have stopped. And we have seg faulted. Okay, got it. Where is it? So continuation f is 0. I am initializing the continuation where I say k is equal, right? So this is the continuation. So this is supposed to be a resumed element continuation end function. Which is a function, which is not 0, right? Or is it somewhere else? Hold on. I want to... let's go back. Target compiled. I want to have a breakpoint where I say k is equal over here. Right? Let's go this way. So k, in this case, is a function kf Wait a second. K is a struct continuation int where f is function type. Wait, oh, this is an implicit conversion that's happening, I think. Yeah. Yeah, here's what's happening, actually. Because, here's what's actually happening. And this is very weird that it is even compiling. But I said the function here, right? I did the syntax, but the syntax is being ignored, and we just have the closure. So this technically is a closure, which is both a function pointer plus the captured context. If we look at the C compiled code, right? Then we see that over here when I'm assigning f to be this function, the type of f is function type, which is a struct with captured and the function pointer, right? But I am assigning to the type, which is this struct, I'm assigning an actual function, and it actually compiles. This is so wrong. Why is C even compiling that? So once again, we just say something like this: type def struct closure. So I'm just creating a closure type like this, you know, void star f void star and void star captured, right? That's how I represent the closures basically. And then we say int main, and I say something like closure f is equal to f, where we just say, I don't know, void f, like this, right? Like, why does this compile? Let me check that this compiles. GCC temp AC, right? It compiles. It doesn't warn. There is like nothing. The function pointer can be coerced to any type. C assign a function to struct. Why is this possible? A structure is used to define data structure to store data. C doesn't allow us to declare a function inside a structure. What? What if I say like if I say int x is equal to f? This also works, right? But I guess this works because the function can be coerced to a function pointer, and a function pointer can be coerced to an int, right? But why would, like, can I say closure x is equal to 1 to 3? No, I cannot, right? Because a value of type int cannot be used to initialize an entity of type closure, aka struct unnamed, right? So why can I do that with a function? Oh, wait, is it f is f? Wait, if I say closure x is equal to f, then it works, actually. Is it because I need a void star captured here, maybe, though? You can make parameters to functions in C. Yeah. F is f there was because I was assigning the variable to itself, which is also like very weird. Why would it not at least warn me there? Why is it even allowed? But okay. Okay, but why does this compile then? If this doesn't, right? Yeah, this said invalid initializer. Very helpful message. Thank you. We're doing this thing. Dot f. F is a function type. Okay, let's copy this exactly as is here, because why not, right? Raw function type is this, right? And we have delimited continuation token int. I mean, it doesn't really matter though. We can just say that it's, you know, int some field. Doesn't matter. And then what we're doing is that. Token. So we don't care about the token, right? And we have a resume. Delete creation. Like so. Also another weird thing is that like I don't need to return from a function and it doesn't complain. That also is like very wrong for some reason. Return 0. It doesn't matter. So, right, like why does this not warn me? Right? Because f is a function type 1. Right? This is basically a closure, right? Which has the captured and the raw function type. We can get rid of this to simplify this further. Like so. Like so. And like so. Right? And this still works. Why does this work? I don't get it. What's the difference between this and my previous example? Void star f. So we have a closure. And we have continuation, which contains a closure inside, right? And I'm just initializing this closure with this function. And that is supposed to be wrong, right? But when I was trying previously to say just closure f is equal to this function, then this doesn't work. But I can assign it over here, even though this type is closure. So I can do it here. I can do it here in the initializer, in the compound literal expression. But I cannot do it in the regular initializer list. What? Any C professionals in chat? I just call it resume function. What? Resume function. Like, isn't this right side supposed to be the initializer for the type of closure, which is same as this right side of the equal sign, but this is something different? Resume fn is not a type of closure. Closure is struct. Yes, exactly. So why does this compile? This line doesn't compile for the correct reason that you are saying, but why does this compile? Because this is a function which is not of type closure, which is a struct. Right? This compiles without an issue. And like, I mean, I guess I can like work around that, but I would like to understand the reason. Why is there a casting involved here, and why is there a casting not involved in this one? Like, what's the difference? What is closure? It's a struct. There we go, over here. It's a struct with a function pointer plus a captured. Why would I be able to cast anything to a closure to a struct? It's not casting, I think. It's something else. It's probably, you know what it probably is? But we can actually, yeah, I think I know what it is. This is initializing the first field of the struct. Is that right? F would be pointing to the address of the first struct element, yes. But, so it's the way the compound literal works, right? This feels so wrong, though. Why is C so bad? Why do people like C is my question, I guess. Because that's just another example of like weird behavior. Void pointers are different from other pointers. Yeah, I know, you can like cast them implicitly. There's implicit casts involved there. Right? So it's because of that. Like if I say that there is like an int x here, it still compiles though. I guess because this is the still going to be converted to a function pointer and then into an integer. If I say that this is a what are the other types that I should not be able to cast into? It's difficult to figure that out. You're assigning to f. I'm assigning to f in the continuation. I guess like we should like we should say that there are different fields, right? Let's say that this is closure C, right? So and this now I'm going to be assigning to C, right? There we go. Yeah, I'm pretty sure I'm assigning to the capture, to the first field here, but I'm just guessing. C compound literal. Compound literals, let's see here. The compound literal expression consists of an unnamed object of the type. Type initializes it by initializing the list. Designating initializers are accepted. What is designated initializers? Around debugger and see, I'm pretty sure that I remember from the debugger it was saying that captured is non-zero and f was 0 there. So I'm pretty sure that's what is happening. GCC GDB temp AC, is that what we do? And then we do like GDB a out. And we do a breakpoint at line 23. No. Why can I not say set a breakpoint here? I don't know. This TUI is confusing. Let's do GDB GUI. A dot out. Fetching assembly since file is missing. Did I not compile it properly? GCC. Is that not what I need? Hello? Why does it say file not found main? What do you mean file not found main? Oh my god. GDB. I need to like figure out how to use this. GDB a dot out. Reading symbols. Inform functions. Yes. Yes, we have this, right? Temp AC, resume FN. Okay. This is the code. Why can I not set breakpoint in main line 23? There you go. Okay, can I now run? Now I'm at this breakpoint. Can I show all of the variables which are in scope in this thing? Examining this stack, is that what I should do? Help stack. This help is not very helpful. People like C is that when you don't use any of these newer extra features. You mean like this compound literal is the newer extra feature? This is too fancy? That's not what you do when you're writing C code? Is there not a debugger in VS Code? VS Code is broken for some reason. And I want to like learn at least like to do it like how to use this once. The help is maybe I need to go to the different category. I mean, maybe it's help data. I don't want to set anything. All right, GDB, GDB, inspect, local variables, printing all global local variables, info variables. Oh, it's info. Of course, it's info. There is not even a section of help which is info. It's not even like telling me that info is a command. Am I blind? Like, how would I know about the existence of the info, by the way, right? Am I stupid? I might be too stupid for C and like GDB and shit. Non-activated Linux debugging experience, yeah. Don't get red debugger. Can I do help info? I can, but how would I know about the info existence? No. Oh wait, maybe help all because it did not show me to help the all, right? I don't know. I don't know how people understand this. So we can say info. Info locals, all local variables, matching regex. Info locals. No symbol table info available. Okay, amazing. Why do I not have the list? Like, why do I not have this? Why does this not work? Why is there no symbol table? Did I not compile it properly? Print f %lp. Oh, you mean like... I mean, yeah, this is the debugging that I usually do, right? Yeah. I do agree with that. That's the debugging that I know how to do. There we go. It's nil, right? So it initializes the first thing. No, it is LP. Yeah. That's right. I don't know why the VS Code debugger, like VS Code it's not even the debugger. I cannot initialize this. Install an extension for C. C, C++. This is enabled, right? So, well, I mean, I have the stuff it's working here, the hover and everything. But I just cannot initialize a debugger. Maybe if I do the file manually, it will work. But why does it not work? I have no idea. What is this supposed to be? What am I supposed to do here? What file? Like a launch, maybe? JSON. CC++, GDB launch. There we go. Like if I can do this, I guess. Is this supposed to be a list here? I don't remember. Incorrect type, expected object. Okay. VS Code launch JSON. Configurations. And this is one of the configurations. Right? Version 020. Name, incorrect type, expected object. Custom is deprecated, use launch instead. Oh wait, it should be an object inside of a list, right? Like this. There we go. So program is going to be a.out. Setup commands. Can I also make it so that it compiles before running, I think, right? CPP DBG. No, I want GDB. No. This auto-completion only allows me to have the CPP DBG. Code LLDB. I think I have code LLDB installed because that's what I was using with Rust before. It is literally installed. It doesn't work. I mean, it could not generate this thing for me for some reason. It said activating extension when I was trying to generate the debug configuration. Setup commands. One more GDB LLDB commands to execute in order to set up the underlying debugger. Set disassembly flavor to Intel. Enable pretty printing. Sure, whatever. We just launched that. Can I make it compile before? Launch compile. VS Code launch compile before launching debugger. How to run task automatically before debugging. Adding a build task to launch. Pre-launch task. Okay. Pre-launch task. Okay. Compile. And then we can have, and then I need to what? Tasks, JSON, right? Version. What else do we have here? Args, Linux presentation, prompt tasks, name. What do we have in tasks? Oh my god. Tasks is called label. It's going to be compile. Type is shell. Command GCC args. 30 minutes later it gives up. I mean, yeah, we could do that too. Well, I mean, I cannot make a bash script for the VS Code debugger to work, right? I mean, I can do like just Like I am using the just file here for my compilation. Also, yeah. I think I keep the F analyzer here. Let's say compile C path is going to be it's going to be that. Right. So say just compile C path. And then I do the compiled. Okay, so over here I will just do just compile C. Well, I mean, in this case specifically, I want a different one. Wait, let's do GCC now. Temp a.c, right? Is what I want. And then we want dash gddb, right? Yeah, that's all. Launch JSON. All right. Can I launch this now? This button just doesn't do anything now. Hello? VS Code. This button also doesn't do anything. Oh, I think this button is supposed to... Yeah, it's supposed to open the launch JSON. But the start debugging doesn't do anything. Is it supposed to, like, at least show me the error if there is an error somewhere? Let's not do the pre-launch task, right? Let's start with just debugging. I'm just supposed to launch the a.out, right? Which is over here, right? Oh, maybe it's launching, but I don't have the breakpoint set up. So I'm not even seeing it like anything, you know? But if I try to set a breakpoint here and then I launch, no, I think nothing happens. Am I stupid or something? Like, why does nothing work? Error. The task compile neither specifies the command nor depends on property. The task will be ignored. Modern software. I'm pretty sure that GDB is pretty old, so I have the issue with GDB too. It's not just VS Code that I am complaining about here. Like, there is no single piece of software that I'm happy with, literally. I think. I don't think I can name anything that I like. Just everything sucks. Never seen that fail. What fail? You mean like this button over here? Yeah, I mean, I don't usually use it. Clear output. Okay, that's like the old output. LLDB. There is no output in LLDB. Maybe I have too many extensions in my VS Code or something. What am I supposed to look at here? Like... tasks. Task. Run task. Compile. Select for which kind of errors and warning to scan the task output. Continue without scanning. Okay, so compile. So the task can run, right? I'm just compiling that. The GCC was happening. That's working. Okay, nice. But the launch is not working. Codeblogs.org. Yeah, I did use the other editors which were working. But I mean, I think there was a time where my debugger was working in VS Code too. Maybe not for C because I never debugged C here. Can I? Okay. Here we go. Let's try something easier. Let's try test.js, right? Console log hello world, right? Set a breakpoint and debug. How do I debug the current file? Debug current file. Godot tools? No. How do I run current file? Is that not a thing? Add configuration. Node. What? JavaScript. Node.js launch program. Can I say the current file, please? Like, why do I need to even specify this? Sure. Let's say test.js here. Okay. Can I launch that one? It doesn't launch it either. I think my VS Code is just broken. VS Code cannot collect debug. Debug in VS Code is not working. Anyone ever had this issue? This is so weird. All right, let's ignore this. Let's not debug anything. Nothing works. All of the debuggers suck, right? Let's ignore debugging. We figured out the issue, right? The issue is C being a bad language, and not telling me the error, and instead doing the stupid thing. Okay. I wonder what is the design decision of that feature is, and like why is it initializing the first field? Is that like that is by design, right? But why would they design it like that? That's what I was looking for. Compound literal. Like, why would you design a language like that? This is a new feature, like you said, right? So it's supposed to be like, I don't know. People have been thinking about this for like at least 10 years, right? Before adding it. Right? Hello, Nerdsoul. Thanks for the sub. 37 months of watching me complain about everything. Right? I was just wondering, where is this documented? Command literal constructs the object. Initializers specified by initializer list. Right? The type of command literal is type. The value category of compound is L value. Its address can be taken. Command literals of const qualified things. Like, it's not even the compound literal that's the issue, right? It's specifically the initializers. Initializers were available in C before the compound literals, right? A list of initializers suitable for initialization. So we just need to look for initialization. Right? Like, the other way to write the same code over here is remove that, and this is just the initializer, right? And this still works, and this would work in C99 too. Can I force like the old C standard or something? X language, specify the language of the following input. GCC force C89. STD C89. STD C89 temp a.c, right? C++ style comments are not allowed in ISO C90. Wait, what? Wait, what? Is the only comment that was available is this one? In the old C, is that right? Okay. Yes, but yeah, and see, this still works, by the way, right? And it is still initializing the same way. So you're saying that this is a fancy new feature, but it's not. This was working like that in the old days too. This was designed bad from the beginning. Yes, do struct field is value only. Okay, I mean, I have not tried that actually. If I do KC is resume FN, you're saying that it cannot be assigned. Okay, yes, we will have the problem, the issue then. That is right. So never use initializers is the rule for C. Is there like a list of features in C that I'm not supposed to use because they are bad? This has nothing to... This isn't like... I mean, I have not read it fully, but there's only one occurrence of the first word, and it has nothing to do with the problem that I'm having. So it's in some other page, and not here. Value initialization in C++. No, I don't care about C++. Whatever. Your philosophy now is that it does not work. It's its problem, not mine. Все же функции не первого класса. The C functions are not first class. It doesn't matter. That's not the issue that we have here. We have pointers to functions in C. I think so. I mean, when you do it like this, it automatically is like there's an automatic taking of the address of the function here, to convert it to a function pointer, which is another thing. Anyway, let's ignore. Let's stop looking into this. I have spent like an hour just trying to make sense of C, but it doesn't make sense. Okay. So I just need to compile the code to the C that works, right? It's pointing to void star and not in star, which is what you're recasting to. What is pointing to void star? What is pointing to void star? Are you saying that when we have the initial, is it the initializer? Is this, when I say the initializer field like this is automatically converted to a pointer? I don't know. I don't know what you're trying to say. It doesn't matter, like I'm not writing C manually by hand, so I just need to fix my existing compilation. I'm just surprised to see that behavior, that's all. And they said the C is a simple language. Okay. We need I just need to fix the type. Yeah. So we have the function types. And function types are potentially raw functions. So if they like, it's either a closure or a function, right? And that's going to be just part of this. A raw boolean, right? If it's not raw, then it's a closure instead. Maybe for better is closure boolean. Sure, let's do that. And we parse type and function type. Root children will get named opt mini syntax. How do I say raw function here? Raw function is it's closure or callable. Well, both closures and, I mean, like, it depends on the terminology, right? I just call everything function, including the closures. And the raw functions. Do I have a has child? Has. Let's do this. Has named tuple t name string. This should return boolean. Self named map. Do I have a map contains? I'm not sure. Let's try to compile this. Contains is not there. Okay. Maybe if I collections or the map. No, I don't want to modify my standard library right now on the Bootstrap. Visually just to get a name, and we're just going to match this. Some true, none false. Okay. All right, so we do that. Tuple has named raw fn, right? So this is I guess is closure. Its closure is not that. There we go. So a function, we have call convention arguments, result is closure. Okay. What's wrong here? Is closure. What is that? Process top level function declaration. There's just some logging. I don't care about that. Is closure is not found in scope. Is closure is false. Parse function. Parse function definition. Yeah, function type over here, right? We need to say that is closure is true for now, because that's what I was doing before. Like I was doing every function was a closure to do. Okay. Resolve type aliases. Is closure. We should ignore that. I should ignore the calling. Oh wait, no. Is closure. Okay. Do 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 do. This is a little weird. What is the error in the mini compiler lib over here? Is it the incremental compilation bug for me though? Let me try recompile. Yeah, the error is different. Function type, yeah, because over here we need to say that this is closure. Initialize function type. Okay. Yeah, this is when we this is in the C backend. If this is a closure, we need to create a different thing. We always create the raw function type. Raw type definition is a function pointer with arguments being the C args. And the C args contains the pointer to void, right? But the C arguments should not contain the pointer to void if it is like this is only there if it is a closure. Only then we have the void star argument as the first argument. I can say with return here, I guess, and this raw type definition and the yeah, we just say that if not is closure, then the type is just the raw function type name is what I need to return here, and we don't generate the struct with captured. I think that's all. Maybe. I will need to have the calling of that function implemented differently, though. Surely C will not allow me to call a struct, right? Or something like that. No, it's the other way around. Now we have a thing which we're trying to get the field of. Getting the fields in the functions probably should not work in C, right? But at this point, I'm just assuming because anything can happen. What is this? This is me adding a function. So we have the function type. Add a function. Function definition. If definition captures is... Neo Ino, hello there. Oh, welcome raiders, welcome. How are you guys doing? What was your... How was your stream? What were you doing?
Change the music.
Reading some books. Book of Proof. What is the Book of Proof? Interesting. Book of Proof. Studying logic. Maybe if I studied logic, I would see logic in the C programming language. I am working on transpiling my programming language to C and implemented delimited continuations, if you are guys familiar with that stuff. And I just had a bug in C where I could initialize a field which is a struct by a function pointer. So basically I was assigning function pointer to a struct, which apparently works in C if you're doing it inside of an initializer. So yeah, and that's weird, I think. Right. So, and what I'm doing right now is I'm trying to have the raw function. So, like I have closures in my language, and what I was doing previously is I was compiling technically every function to a closure. It's just like those freestanding functions are capturing nothing, so the yeah. We represent the closures as a function pointer plus the pointer to the captured environment, right? And for the freestanding function, the captured environment is just null. But now I'm just introducing the literally raw function pointers, which are not allowed to capture anything, so that we can, like, because that's present in C, and I need it for interoperability, I guess. So that's what I'm doing. I just added the isClosure field to my function type, and now I'm trying to compile that. Cast proposes ultimate power. Yes, cast is supposed to be ultimate power. And this on the screen is cast already. I am writing minicast. I'm working on minicast right now, technically, which is written in cast, which is a lower level programming language, which I am transpiling to C. And the original cast, the bootstrap, is transpiled to JavaScript instead, because and now that I'm looking into C, transpiling to JavaScript was the correct decision. C is a weird language. I don't like it. Not that I like JavaScript, but at least debugging it is a lot easier, I think. But yeah, all the programming languages suck. That's why we're making our own one. Yeah, I'm making a language in my language. This over here. This, I am working on the self-hosting, right? It's just the self-hosting. We start with a simpler version of cast, right? Which is close to C, I suppose. And yeah, we have already like almost 20,000 lines of cast code here, right? Yeah. What is that? Terminal environment changes. How did I even open that? I'm actually like thinking that minicast could be a standalone language, and I am considering working on it more before self-hosting cast. But I don't know. I don't know yet if I'm actually going to do that. But minicast is supposed to be a simple language. There are people who like simple languages for whatever reason. Instead of a powerful language and safe, right? So we're adding the function here. Bum, 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 bum. What was the error? Over here, right? So I am creating a function. We need to know what is the function type. Is closure is true. This over here might need it to do though. I'm just going to keep all of the functions to be closures for now. You can see actually in the C code, right? Maybe I can show the transpiled C code here. Target compiled C, right? For example, over here we have print int, right? Print int. So this is the definition of the function. It's just some inline C code here. This is a freestanding function, but it is still a closure. So it is a struct with the f function pointer and the captured environment. But in case of a print int, the captured is literally null, and we have print as close. So we are basically going through the indirection here, so I should get rid of it because this is supposedly overhead, although I think the C compiler would see this and inline that, right? Because we have print int as closure, which is just calling the print int standalone function here directly, right? But I could just only have this function without having a closure and a struct. Although sometimes when you want to basically convert a function, like we want to convert the raw functions to the type which is supposed to handle closures as well, right? For that reason, we would need the print int as closure, I guess. Anyway. Init function type. Make sure all types are defined. Over here is closure. That can be ignored. Okay, it compiles. It probably will not work. Just see. Right. Because a resumed element continuation token is a raw function type. This should not be. This should be a raw thing. Yeah. Okay. Captured is null. What is this? This is when I'm making a constant, right? Yeah. What is this line of code specifically? We have a resumed element continuation token int. It is supposed to be a raw function. This is runtime, I think, right? Resumed element continuation token. This is just a regular function. So the question is, why is this a raw function type, actually. That's not what's supposed to happen, I think. Is closure. Not here, in the mini compiler. Lib, I guess. Disclosure. No. Parse. When am I parsing the functions? Over here? Disclosure is false. No, I should say disclosure is true always, right? When I process the top level function declaration. Top level function for now should actually be true here. Because I'm going to keep the current behavior. No. Is closure is true everywhere, right? If it's true everywhere, then why would that not work? Let me take a look at the type definition here too, right? This function type is the function which just takes that. Yeah, that makes sense. Oh, wait a second. I know why. I know why. They are considered equal types. They're considered equal types because over here, right, I have the comparison function. I have compare types. It is not derived yet, but it should be derived. And because I just kept, like, I added a field, but I did not say how we compare the function types, right? Because if the we just should say that CMP is std CMP default compare boolean. A is closure and B is closure, right? If CMP is not equal, which maybe we should have a syntax sugar for is not, then we return CMP here. There we go. So it would actually depend on the order. The things are being compiled in because of the wrong stuff. Yeah, there we go. So now the other issue is that we have the continuation.f, right? And now the continuation.f, this is the raw function pointer, and we should basically get rid of the captured, and we should get rid of the .f field here when I'm calling the raw functions. Right? So this happens when we have the apply expression. We have this is the function type. So this is the argument, which is the captured. It should only happen if function type is closure. Only then we have the captured argument, and the function itself is if it is a closure, then it is the field f of the function of the closure object. Otherwise, it literally is just f, right? Yeah, sure. I think this should work. First try easy, and okay, we just detected some memory leaks, but that's perfectly fine, right? We just leaked 16 bytes in one allocation, but let's see. We are capturing continuation, resume assigned 456 123. I think it works finally, and we can start playing around with it. Right? It seems like move closures were actually implemented. I thought for some reason there was some issue with the closures. Oh yeah, the issue is the malloc. I think this is what we're leaking. What I'm leaking is this, right? Yeah, literally the mallocing of the captured, right? Because in this case specifically, this over here is a closure, which is capturing the continuation, K, right? So I am storing this in a on the heap using malloc, and I'm not freeing it ever. All right. Should the freeing be explicit? I guess, right? I think what I want is to free closure returning int resume, because I have called it right, and this is a function that is supposed to be called once. Sure, maybe runtime mks. Let's see. Free closure. So we have return type, and f is a function returning r. So we can just do native free f dot captured. Are you allowed to send null to free? I guess we can say if f captured, then we free it, right? Yeah. And this gets rid of my memory leak. Okay, I probably want to look into these warnings. I don't like them being here. The reference of null captured potentially. Because MCO get user data can potentially return null. Can I get rid of this by using an assert? Print string.f string view. What is that? Use of uninitialized value unknown. Which one is unknown specifically? CC110, use of an uninitialized value unknown here. Where is here? Closure 71 function. Oh, because I print that. What? Closure 71 FN. It prints resuming continuation. We call print string and closure. What exactly is uninitialized? I don't know. Anyway, my code works. That's what matters, right? We should try playing around with this a little bit. Let's let me get rid of this stuff. That is all okay. Test.js can be moved to trash. A.out. No. Don't stash it. A.out can be moved to trash. Like, we just installed GDB and Valgrind. Compile C, that's okay. Delimited continuations. Okay. Delimited continuations work. Maybe. Okay. Let's try to write some code, right? What would we want to do here? Oh yeah. The stuff that I want to do is this generator example, right? So we convert generator to iterator. Does this work? We want a generator like that. Okay. Resume. Right. Yeah, so in this case, resume now is the continuation. Right. So this should be just like before. We convert this to a closure. Or should I just say that new resume? New resume. Yeah, can I just say that new resume is continuation like that? But now we cannot just call resume, right? Now we cannot just call resume because we need to say resume continuation. Continuation returns continuation generator to iterator resume result, because we don't infer the arguments yet. Okay, there is a pattern match which is non-exhaustive actually over here. What is that? When I'm converting the type, oh yes, because I'm storing the token. Wait, what? Yeah, it says the limited continuation token, where the representation is that. Yeah. So similar to unwind token, if we have the delimited continuation token, where we have the representation is wrapper and result type can be ignored, and we just convert the type representation. Error field new resume as incomplete type. Continuation. Okay, we actually have an issue here because this is what? We have a mutual recursion on the types. Do I? I think the reason for that is what? Because I have a function type which which is returning this type. So yeah. Let me test something and see here. If I have a type def struct foo, and this wants to have no, not type def struct foo, right? I want to have a function which returns struct foo. Return foo, right? I can specify this function without knowing the type, right? And that is only needed to be known when I define the function, when I implement it, right? Yeah, that makes sense. But when I'm saying make sure that all types are defined, and if it is a function, then I'm actually making sure that all the types are defined for the result, but that's not really needed, right? Because type can be forward declared for pointers, and same is true for the functions. Actually, do I even need to have the yeah, so this is true for the for the result type. Is it also true for the argument? Struct go arg, right? This also, no, declaration is incompatible with struct foo. What? What do you mean? Oh, struct goo declared inside parameter list will not be visible outside of this definition or declaration. I can just say goo here, right? But this is not defined. Can I say type def struct goo? I can do that though, right? And yeah, this would be incomplete type, which is still working. And same can be done over here with type def struct foo, but this is incomplete type, but we can use it here, right? But if I define struct goo, which contains the foo inside, that is something that is not working because this is the incomplete type. Okay, got it. Now that part of C makes sense to me. I just do the same. So make sure all types are defined. This is like a little bit of a misleading name. It is make sure that all types are defined for defining this type, right? Make sure all all dependencies all type dependencies are complete. Maybe complete if needed. Is there a better name for it? If needed. Okay. So I don't need this comment here. So the yeah. Boom 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 boom. So when we have a function, I don't need to complete all of the types here at all. Of the arguments or result. We don't care about that, right? Which means that I don't care about any of these. So we just get to orientate the function type. Okay, sure. Now what? Error. Initialization of M-core from incompatible struct limited continuation. Closure 57. We have X. Resume limited continuation. Token. Apply result 60. Sum int. This is a closure that returns sum x. This is the one, right? Yeah. This is the closure. And what is wrong here? Initialization of M-core from incompatible pointer type. Token. Wait a second. Hold on. This is the same bug. This is the same issue. I think this is the same issue. Wait, there's no way. It's trying to initialize the first field here instead of initializing that. Hold on. This is so wrong. So it's not, it's always initializing the first field there instead of initializing the actual value. What? Excuse me? Let me minimize this example, right? So we have something like this: type def struct foo, and we have like int. Let's say int. Int x, right? And then we have a type def struct which contains foo, which has foo inside, right? So then we say something like this: contains foo is the thing where foo is equal to foo where x is equal to 1, 2, 3. Right? Wait, no, this works. Or maybe it doesn't. Hold on, GCC. No, it does. Wait, this captured stuff has a pointer to pointer, by the way, dilim. No, this is because it's a different type, I think. Yeah. Like if I have a reference to that. Right? In this case, it says initialization of int from foo star, right? Because it's actually trying to initialize this field here instead of initializing that field. Oh my god. Okay. Never do that stuff, right? Okay. Maybe that is a good suggestion that we had. That we just don't use this feature of C. And we should always initialize field by field on separate statements. Okay, but I think the actual issue is that this is a pointer to pointer, and I'm only dereferencing it once for some reason. So the question is, why is it a double pointer? Because in this case, it's a reference to a delimiter. Why mini coroutines? The bigger the better, make them huge. Well, I mean, they are huge. Addition to a language, I suppose. But I'm adding them to minicast, not to cast yet, I guess, which is why they are mini coroutines. And also because I'm just using a library for C, which is called mini coro. Yeah. Hello, Sturdy Pose. How are you doing? Are you a C fan or not? I have hit this issue. C++ is better than C. I would assume that this feature specifically works the same in C++ though. So here's the thing. We have a struct which contains another struct, and then I initialize this struct using the initializer list, and then I initialize the inner struct using an integer. So I'm basically, what this looks to me is that I'm assigning an integer to struct foo, right? Even although if I do normally foo is equal to 2, this would be resulting in a compilation error. But when you do it inside of an initializer list, it is not a compilation error. Does it work like that in C++ too? Because in that case, both of these languages are trash. Why would it work like that? Can anyone explain the logic behind this? Because I don't get it. And what it does, I'm pretty sure, is that it initializes the first field of the field that I'm initializing, instead of initializing the field itself. Does it work through double indirection, by the way, I'm wondering? So if I say like over here we have goo, you know, and over here we say type def struct goo, and we have int x here, you know, can I do that? Yes, and it works. It assigns to the double nested field. What? In C++, you can have explicit constructor, which you should always do for one argument constructor. No, so that shouldn't be possible. Yes, but if you... But the default behavior would still be the same, right? I mean, let's just rename this to CPP and see if that works, right? And I think it does, right? So if I see G++, temp a CPP, then it still works. So it is possible. That's how it works by default. But you can opt out of this wrong behavior. It's because like the default constructor, right? Because when you say initialize this, you're technically calling the constructor of this object, of this field, right? You call the constructor of this field with this being the argument, right? So like if I was to write this default behavior in C++, what do we say here? We say like foo. Well, I mean, but the default constructor is something like this, though, no? But that now doesn't work, right? Because there is no suitable constructor that exists to convert. So like, what is the default constructor? Is there like no even... is there no like direct way to write the default behavior explicitly? It's not due to the type def, no. Can you elaborate? Like, is there a way to explicitly write the constructor which is generated by default if you don't write the constructor here? Like, it should be possible, right? To do that same thing explicitly. That is being done implicitly here. Foo is default. You mean this? No, I mean like so that this code still would compile, because if you say foo is default, then that's... Wait, what? Why does this work? What is the constructor that's being called here? Or does it mean that... Oh, we need to do a semicolon here. Hold on. Does this actually generate... Oh, it generates the overloads. I see. So when you say it equals default, it also generates the overloads. And what are those overloads? So it generates the overload automatically for all the overloads of the goo constructors. Is that right? So all the constructors available for the first field are injected as constructors here? No, I understand the custom constructor. I just don't understand this default behavior. The default behavior is what is like really wrong. It's not just wrong. It's like horribly wrong. And that's the same behavior as it is in C. And I just don't understand the logic. Why would they implement the language like that? It makes zero sense to me. Because it it leads to really bad errors. Not sure what doesn't make sense. What? Okay, make sense of this. I'm initializing the foo, which is a struct foo with the value of 2. How does that make sense? Does that make sense to you, really? I don't think it makes sense. And it works like that even if I have multiple fields here, right? Like, shouldn't I mean, I guess I would understand it maybe if it was a struct with a single field, so that we can like have a value for the only field. But if it is multiple fields, why would I only want to initialize the first one? I mean, there are, like, most of the times I would want to initialize them all, no? You don't like aggregate types anyway? What is aggregate types? It's just a struct here. What is, what is an aggregate type? That's not a thing, right? It's the aggregation, which is initialization, which is aggregated. Or what? Initializing aggregate types. What is aggregate type? An aggregate type is a structure, union, or array types. And you don't like them? How can you write code without using structures, unions, or arrays at all? Is that possible? Even? Alright, anyway. So I think my issue is that I'm capturing the thing twice. Right? Yeah, there is like this captured. There's a closure, which is yeah. Let me see the code here. Generator, right? So this closure captures delim, and delim is being captured because we have delimited continuation. So this over here is also a body of a separate closure, kind of technically. So in this case, I'm capturing the continuation directly, and in this case, I'm capturing the continuation inside of a closure. Yeah, makes sense. I think the issue is when I'm initializing it, though, probably. Yeah, why is the type here a double star? It should be a single pointer. You're saving some CPU cycles perhaps by using them, but they're so annoying when you change something within declaration and now you have a compiler complaining. What? How do you write code without it? Like, I mean, what are, I mean, if you write code without using structs, then like, what even is the code that you can write? I don't understand. I mean, in some cases, I guess you can replace with the structure with like 2 separate variables, I guess. But All right, I'm not sure what you're saying then. Not sure what you are saying then. By not using what, I'm saving some cycles. Some type default in it. Type something is 3. That's how you write code, right? So so you're saying that you don't like the initializers like I'm doing, right? So instead you say that we should like do it in that way, right? Or where we initialize it field by field instead of using the initializers. So you don't like initializers, not the types. Okay. I mean, I don't like them now also because they are like they're horrible and they are very easy to misuse. So yeah, I would probably prefer to do what you're saying too if I was writing C or C++ too. Aggregate initialization is the way. No, there is no way. Like, I mean, sure, maybe I hit this bug and like, no. Like because of the refactorings that are happening, this is just going to be silent bugs eventually. Because of the instead of initializing the field, I initialize a field of a field on accident. Even although that's not what I want to do. This is just stupid, in my opinion. It might work like because you remember to like that this is how it works. But when you change your code base, like the bugs are just going to happen and you're going to miss them. But I could see that in C++, you should be using the explicit constructors because that would opt out of this behavior. Then you use that instead of the two-phase initialization, which is supposed to be better, I guess. Boom, boom. You're using what's called designated initializers, which are a new thing. No, that's not true. Oh, C had them for... Okay. C++ just got them recently? Okay, yeah. Because, like, I was literally trying to compile this code with C89, and it still works like that. So, this is there from the very beginning. This wrong behavior. It's called designated initializers. Okay. So C didn't have it. So C++ was a better language than C in this specific case for a long time until C++ 20, and now C++ is also as bad as C. Got it. In this specific situation. All right, so I think what's happening here is something like that. When I'm capturing, so I'm capturing twice. Actually, let me do another test. Can I just have this test, right? Let's do this. Const main. We'll just do this. Let f is a closure which creates another closure inside, which return, which I don't know, print, which prints string hello, you know, like this. And then this closure is being called immediately, this closure is being called immediately, and we say that hello is hello. Right? Does this code work? Because I would expect this to be the same issue. Detected memory leaks. Oh no, wait, but hello was printed actually. Oh yeah, because I need to free closure F, right? This closure returns nothing. Yeah, then we don't have the memory leak. There we go. So this actually works. Okay. So the problem specifically is if I say delimited continuation, we have the delimiter here. No, right here just capture continuation delimiter. Okay. Maybe this is not going to work. Yes. Okay, that's the simpler example. I don't know why it doesn't work with the double closure. So the issue is here when I'm constructing the continuation, right? Because the delimiter here is a double pointer. Okay. Why? Because the delimited stuff captures the delimiter. Oh, because this is a delimiter. Okay. What if I move this, by the way? If I move, then the delimiter is just a single pointer still. But it should not be. Yeah, there's like an extra pointer which is happening for some weird reason. In the closure. When I initialize, and now when I initialize that, a value of top struct cannot be used to initialize a pointer to the struct, right? It's just that the type is incorrect here. That's the only issue. The type of the closure captured environment is incorrect for some reason. Where should I look for that? It's not the delimited captures. It's the function. So that's when I am add function impl. Capture mode captures. Oh, this over here, right? When I'm adding it. Yeah, but I'm not. Yeah, yeah, over here I'm adding a function. Add function is called. So this is the top level functions. And when we have a closure, yeah. Okay. So we create the type, captured, field is captured to field depths. Which it's just going over this thing. So I think it's just like calculating the type incorrectly here. So that's before the C backend in the compiler here somewhere, right? Captures. Captures add, right? I have the incorrect type. Also want to say like where, I suppose, at span print. Do you have a span here? Yeah, we just say definition span. Right, so type is not type. found in parent. Yeah, and the reference type here. Unmatched value delimit continuation token. Over here, I'm printing the type name. Got it. I didn't implement printing of delimited continuation token. Delimited continuation token. Yeah. Okay. So yeah, see, it's capturing delimiter over here. So this is the closure, and it's capturing the delimiter, and the type of it is a reference to the token instead of it being the actual token, the owned one. Why is that? That's because of how I'm compiling the expression of the delimited continuation token type. Right, because I'm adding to the current scope the variable of the token to be the token type, which is a reference. Yes, there we go. Why is this a reference? Maybe I was going to do a reference because I am doing a reference in unwinding, I guess. I think I just get rid of this. That was just a reference there for no reason. That's all the bug that I had. Maybe. Expect a reference to the delimited continuation token. Got this over here. Yeah, because when I capture the continuation, it expects the token. It expects the reference. Well, I mean, the reason for that is because I am doing the references for unwinding. But the reason for the references in unwinding is because if I am out of the unwinding block, I'm supposed to not be able to. I'm not sure how it works with the continuations, because when I'm out of this block, there is still the continuation that is alive, right? Potentially. Yeah, let's just get rid of that requirement for the type checking too, which is the capture continuation. It's expected delimited continuation token, right? So this should not be a reference, but a delimited continuation token, like that. And that's how I implemented it in C already. Python match is non-exhaustive over here. Make sure that all dependencies are completed if needed. Okay. The limit continuation token. We'll make sure that the representation is there. Yeah. All right, it's going to work now, right? No. Oh wait, I wait. Hold on. I specify the variable of type void, and I'm returning void too. Oh, because this is a delimited continuation. So yeah, I guess I did not make it work with the continuations returning nothing. Let's fix that too. Result. This is right, delimited continuation. If expression type is unit, then we do that. That's the body. This is what, but this is a resume delimited continuation token, the unit fn. A result. We just declare the variable. Oh wait, it's because I'm popping it. Oh wait. Is this the correct thing? Can I do a size of void? Is that something that you can do in C? Why does it say 1? Why is size of void 1? Is that right? Printf %d and size of void. One. Size of void is 1. This is a non-standard extension of GCC, but has a rationale. When you do pointer arithmetic, adding or removing one unit means adding or removing. What's defining this? Helps defining void star as a pointer to byte. Otherwise, it's surprising behavior. There, p plus 1 is equal to p. Okay, it doesn't matter. What matters is that we have this resume continuation, right? And what I'm trying to do here is the pop thing, right? So in this case, the t is unit. Wait, but I also thought that we actually can have the empty structs, right? We can have empty struct, and size of foo is actually going to be 0. So this rationale for the void star being 1 is weird. Because we actually have the things which are of size 0 in C, right? Is it 0 still in std C89? And then I can initialize it, right? Yeah. Maybe like in this case, I want to create a type which is unit as something that's different from void. Wait, what if you say that you have the array of 100 foos? Then what is the size of this thing? Still 0, right? Okay. And then wait, hold on. And then we can I say foo p is foo like that, right? I can do that. And then I can say p plus 1 for the second element of the list, right? So this is p0 and this is p1. It prints the same address, right? Maybe we don't need the L. It's just a pointer, right? So it's the same pointer. So this logic breaks completely. But if you have a void star, and then you say void star plus 1, then it's actually going to be a different pointer. Okay. Interesting. Yeah, but how do I compile this code, right? So because I'm trying to inline that, I should have like a different compilation in case this is a unit. Because in this case, I only want to have a resume and there is nothing to pop. Even. Does MCO pop even work? If the length is 0. It works. If it's 0, then we just don't do anything. Okay. But I kind of just want to get, like, if this is a void, then I just don't want this to be here. Right? And I guess we can also maybe I can leave this mini cast code as is. Basically, if I have a reference to the unit type, like this is just going to be completely erased from the output, right? So we don't even have the variable at all because the type of it is void anyway. But I need to make sure that size of this thing. I cannot say size of this thing. Unless I... And say special case where an expression of type void is compiled to void. But when they have a reference to something of type void, this should literally just be null. Because it doesn't matter. We are popping null. This is like 0. We can also do the size of instead by having the this argument to be what? Type info. Because I had type info, right? It's just type info t.size. Yeah, we can do that instead. So unit, yeah, there we go. We have unit type inform. Oh, wait a second, but unit type inform. What is it? What is it going to be actually? Unit type inform. Unit type info is this, which is actually, because like I'm actually compiling this to be equal to the size of void, and this is going to be 1. This is wrong. This is wrong. I want the size of this to be 0, because otherwise... Because this is undefined behavior. This is wrong. I guess I can special case the type info for the unit. What's a line of void, by the way? I mean 1, I guess, right? I think, yeah, I think if I fix the type info, that will be fine. Type inform. Construct type inform. So if this type is unit, then it should not be the size of void here. That's the thing, right? Yeah. Size. Stride is equal to size right now, yeah. Yeah, we will special case this here if let size stride alignment be if info type is unit, and let's just do that. Then it's just going to be 0 0. What should be the alignment? Alignment would still be 1, maybe, right? These are expressions here. C expressions. Otherwise, we'll do that. It's size, size, and align. Okay, well, I mean, let me just fix in the unit info, unit type info size, right? Because now this is 0 0 1. Okay, special case for a unit, because size of void doesn't make sense. Okay, and then now I just need to get rid of initialization of the variables which have the type void, right? Because C doesn't know how to do that. So if I have a let, I'm not going to even do a let if that thing is if the type is void, right? So if value type is unit, then I'm just going to return the void. I am going to still, I guess, calculate the value though for the side effects, but we need to not create this variable in C. And then when we have the address of, right? So I want to calculate place. If we have a place which is an identifier, we say find identifier. I guess there's also going to be an issue when I'm capturing something of the unit type, but that can be fixed later, maybe. I think what we need is to just have a reference. We have a reference to me calculating place.get. Right? But this is going to be a null in case this is a void, right? If the place type is void. Yeah. So I think if I have a reference, then we say that if place type is unit, then I'm going to just return expression is some. So this is going to be, instead of a reference to some variable, it's literally going to be null, right? Otherwise, we actually do a reference to the place. I mean, I still need to calculate the place though. Place expression. Because I calculated in any case for the side effects once again. Okay, and then so I gotten rid of the declaration of this variable. I gotten rid of the reference to this variable. Instead of this is null, and now we also need to not return void ever, right? Return result. When do I return? If result expression is some expression. Oh, yeah. Then we insert result. Calculate. I just don't need to insert it if body type is unit. We don't do anything, otherwise we return. Sure, let's do that. Although maybe just the result expression should be none, because it's not stored anywhere if it is the type of unit. Yeah, maybe that is better. Actually, let me do it in a better way. So when I say calculate here, yeah, you know, like over here, I'm calculating the place and I'm getting it here. Like this should actually return void if the place is of type void, right? Place expression. We say place is calculate place, right? But I don't actually get it. I think I should never try to get the place, and they should panic if I even try to do that of a void type. Right, so I say that if place expression type is unit, wait, no. I can keep this as is. It's just when I calculate the place, right over here. Get expression is, this should be just none, right? If the identifier I would like to know the type of it, right? Find identifier. It's in 3 places. In assignment, and in calculating the place. I should be able to know the type of it by having expression type and the type of this is what is this? Construct captured. These are the captures. Yeah, I actually know the type of it here. So this is literally the type of the captured variable. Okay. So yeah, now over here, I just say that if type is unit, then none. But otherwise, it is some identifier expression, right? So I don't even like create the reference to the identifier at all. Yeah. And when I try to set this, we also say that if type is unit, then I don't need to generate the assignment. But I guess in this case, I'm going to insert statement, which is expression value, because we still need to like evaluate this for side effects if this is not a pure one. Okay. Reference doesn't have fields like that. Okay, it's compiled. Nice, and it works. That's the little test here, though, right? And then let's do the actual test. Generator. Is it going to work? We have stack use after return. Okay, got it. It doesn't work. I might need to just have some of the closures to be moved once. Like what over? I think over here maybe. And that's the yeah. Although I mean this one doesn't like really matter, does it? We have stack use after return. Okay. Okay, let's see what's happening here, right? I'm not printing anything, so let's see. Have I converted like we want to get this generator to iterator, right? So let's print string 1. Right? I should be getting here for sure. Right? Now, am I getting over here? Am I getting over there? 1 1. I am. No resume is resume. Oh wait, no. I remember now. There was one thing that is missing. I'm creating this delimited continuation, which is actually supposed to own this value, right? Like delimited continuation blocks are similar to the closures, and because like yeah, they are literally compiled into a closure. And sometimes I want to move the thing into it. In this case, we're moving the generator function there in order for it to be called. Yes, because we are going to call it. That makes sense actually. I need to move delimited block. Okay. So mini syntax. So similar to move block on the function, we need to move block on the delimited continuation over here. Okay. So it's not 2 children. Token AST is root tuple can I have it dedicated for the function. We actually have AST helpers get child AST token, and same for the body. And then we say that capture, yeah, over here, this capture mode, that's what we do, right? We have a by ref, which is a to do. So we say that if root children capture mode, yeah. Tuple has named move. I guess we do like this. There we go. Move. If it is none, then it is by ref. Okay, there we go. And I think that's the only part, because I didn't have the syntax for it. And now I have. Okay. Easy. Actually, it works first try. So, so this example is when we convert a generator to an iterator. So a generator is a function which is just sometimes calling the yield, which is pausing the execution of that function and then resumes later. And iterator is something that we can just say, get me the next item. So iterator is basically holding the paused execution of the generator inside. Okay, nice. Done /n. Done yielding /n. This is nice. Why does it not say that I'm leaking memory, by the way? Because I am not freeing my closures here, am I? Was it not supposed to tell me? That the captured environment for this, because this is capturing the lim and yeah, it's capturing the delimiter, that's all. Yeah, hold on. Am I not supposed to get complained that I have a memory leak? What? Take a look at the compiled code. A 1,000 lines. Like I'm doing the malloc, right? Well, I mean, I guess we also have these mallocs which are never freed, and they are fine. But this is a global variable. I mean, I'm storing this in a global variable. What is this? A function delimited continuation token generator to iterator resume result int generator to iterator resume result int nf type info. So there is a couple more mallocks over here, right? That when I'm doing the closure, I'm capturing the delimiter here, right? I'm never doing the free. I'm literally never freeing anything. But it's not detected. Okay, but this is good news that this example is working. Okay, working generator to iterator. This is nice. Hold on, let me check. Yes. I committed a.out for some reason. I should not do that. This log info, I think, would be a debug. When I'm capturing something, I don't need this right now. I don't need this anymore. Working generator to iterator. Okay, nice. So now we have async, basically. Right? Should I try a more complicated example? Like, I would like my like this is written in cast though, not in minicast. This one is missing the async. Ness. What is the classic async example? Async example. I don't know if I can come up with a simple example. There's still some things here that I don't like. in this example specifically. One of them is that I am capturing the continuation immediately after constructing the continuation, which is not very efficient, right? So the async blocks, like in Rust and I guess in C++, the coroutines maybe too. I don't know how it works in C++. But they don't start executing immediately, right? They instead give you the object that you can drive to completion. And technically, like, I can do the same. So when I construct the delinquent continuation, I get the continuation immediately, is what we could do. And then we can just rename this to the async. It's just not the await that we have. What a different thing. Because the awaiting is still awaiting is basically implicit here. The main reason though I don't like it is because of the uninitialized stuff, right? Because if I got so like I'm just getting the original continuation here, like this, by capturing it and then just storing it. But in this case, I don't need the value. But in the later continuations, I actually want the values and continuations also, right? This also looks more like a generator. Like there, like in this. I mean, this is literally the example of a generator, right? But like over here, when I'm capturing the continuation, I'm like yielding, and then there's also a final value, which is potentially of a different type, right? Because over here, there's also an initialized. Because when we finish the generator, we just need to return none from the thing, right? Well, I mean, technically, it is fine in minicast. In cast, this would be a the algebraic data type, which is either a yield or the end of the iterator, I guess. Yeah, I guess we can have generator to iterator result is a struct. Instead of saying values option T, we can say that the yeah, instead of saying that value is option T, we can say that yielded is a boolean, right? A value, I don't know, I guess finished is a boolean, a value is T, and value is only present if we are not finished, right? And new resume is also present only if we're not finished. So it's kind of like an optional pair of value and new resume, right? Yeah. Although in this case, we say that finished is also uninitialized value new resume. So in this case, value is uninitialized because we're just finished, true. And in this case, we say finished is false, value is X. Right, so I don't need an option for that. Well, I mean, we do need an option for the iterator, I guess. Yeah, so we say like this resume, and we say that basically if resume finished, then I just return none. right? Otherwise, we return some resume value. I don't know if that's cleaner or not. Yeah. That's the same stuff. No? Not resume, result. There we go. All right, I'm not sure what the next plan is. I can see two paths here going forward. I either like, so the original plan was, so this is minicast, right? So the original plan is to compile cast to minicast, which I think it has all the primitives now. I think, I'm not sure, but I think it has. And then that works, and then we keep working on the self-hosting of the full cast. Or the other option is to turn minicast into an actual programming language by which is simpler than cast. So like improve that language instead. I don't know. I like both options. It's just this is easier to get to a like relatively finished state, I guess, the minicast. But then ideally I would want to self-host minicast, and we already have a lot of code in cast, not in minicast. We'll see. What I'll think about it. What are the next steps? I was also going to play around with these continuations a little bit, but maybe off stream or some other time too. Learning to code so I can take AI's job. Nice.
Executed are ignored. If none of the if or
Alright, thank you guys for watching. See you next time. Bye.